Hi, in this episode, if you have 30 minutes, let me do a Form 4 Chapter 3 Gravitation recap with you. All you need is just a piece of pen and paper, suitable if you have just 30 minutes of time and you want to do a recap of the chapter. So let's start. Now, in Form 4 Chapter 3, this is actually what we call the Gravitation chapter. Now, in Form 4 Chapter 3, the first thing that you have to understand, there's this thing called the Newton's universal law of gravitation. Okay, first of all, guys, what is the universal law of gravitation? You have to understand that this is the one that gives us the first formula whereby we use gm1 m2 over r squared. But please do realize that, do you see that I actually use big M small m? So in this video, instead of m1, m2, I will use big M small m to represent the bigger object, big M, and the smaller object, small m. What about r? So a very common mistake between students is that they like to say r is the radius. Now, if you check the definition, it is more appropriate to use the word distance between the center rather than radius of the object. Okay? For example, in what situation can we use this formula? Now, in Newton's universal law of gravitation, we can calculate attraction force between two objects. So let's say me and my friend. So me and my friend, which is now standing maybe 5 meters apart. So guys, am I attracted to my friend? Is my friend attracted to me? Now, according to universal law of gravitation, as long as the object has mass, no matter where you are, as long as you have mass, you might be a remote control, you might even be a book, but as long as two objects has mass, there will always be attraction force. So am I attracted to my chair? Am I attracted to my phone? Am I attracted to my bed? The answer is yes. So we can calculate what is the attraction force if I sub in the small mass, the big mass, the distance between their center, not radius, and then you might be curious. So what is this G? So this G is actually a constant known as 6.67 multiplied by 10 to the power of negative 11. So of course there's a unit which I won't talk about in this recap, but this value will be given in the exam. So don't you worry, you will just use this value and calculate out the attraction force between things and person and planet. So here comes the question. So if this guy, let's just say this guy is Jung Hao, and let's say this guy is another person, let's just call him Lee. So what happens here is that if there is attraction between me and Lee, why are we not moving towards each other? Why are we not attracted together? So guys, if you want to, you can sub, let's say a normal human being is 60 kg versus this guy is like damn big, is like 100 kg. And now we are standing 5 meters apart with this gravitational constant. How much will this force going to be? Now, if you try to calculate this force out with your calculator, you will realize that this force is very small, okay? Now, if the force is very small, so small to the point that you will hardly notice it because it will be maybe times 10 to the power of negative 5, negative 6. So it's 0.00000001 Newton. Okay? However, there is such force, it is just too small. Kalau macam itu, then why are we attracted to planets? Now, obviously, if you compare planets to my friend called Lee, a big planet here, maybe let's just say Earth. Earth might be 5.97 times 10 to the power of 24 kg. So if this is so big, then obviously the force is going to be very significant. You will be able to feel the force and see the force. Okay, so we call this the first formula. Very simple. Now we will use this formula and we will change it to the second level of formula. So my second level formula is called the small g. It is not called gravity because a lot of students, right, the whole chapter is about gravity, guys. So what gravity is this? So for this small g, there is actually two names. So number one, we call it as the gravitational acceleration, or number two, we could also call it the gravitational field strength. which is n kg minus 1. Now, if you have sufficient knowledge in derivation, you will realize that they are actually the same unit. So how do we calculate this gravitational acceleration, also known as gravitational field strength? So the formula here is going to be gm over r squared. So I will not touch derivation. How do you derive this formula based on this 30-minute recap? But yeah, I just want to show you all the formulas there are. So this is my second formula, calculating gravitational acceleration and gravitational field strength. Okay, so it's very simple. One thing to note, guys, so when you are at Earth's surface, 1 kg is equivalent to how many Newton? So I'm very amazed that I have students who still tell me that it is 10 Newton. No, guys, it is 9.81 Newton since the beginning of Form 4. Alright, 10 Newton is used in Form 1, Form 2, and Form 3. So this 9.81 is also known as your gravitational acceleration. When you do calculation involving free fall, so your object fall down, there's an acceleration of 9.81. So after Formula 1 and Formula 2, we will then go and introduce you a new member after the Newton's law of gravitation. What is our new member here? So we're going to introduce something what we call centripetal force. So guys, what is centripetal force? So if gravitational force, we usually will just write a mini g, okay, because there are so many forces in physics. You have electric force, you have magnetic force, you have gravitational force, you have centripetal force, you have resultant force and the normal force and reaction force, and the list goes on and on. So if next time you see my video and you see I write F small g, that means that that is your gravitational force. What about centripetal force? I usually do FC. So centripetal force is a force where it is possessed by an object that is going in a circle. Now, so for a circle object, let's say if you try to tie an object, and for this object that will spin, if you try to just take your USB cable and you start to spin the USB cable, you will realize that you are exerting a pulling force that goes towards the center. Alright, and if you're trying to spin the USB cable, who is spinning the USB cable? You are the person who is exerting the pulling force, and pulling force also means the tension force, which is equals to the centripetal force. So centripetal force is a force that will act towards the center of your rotation. Okay, however, is there any other trick questions? Yes, there are. So sometimes they might say that if they hang an object and then they spin the ball. So when there is a hanging of an object and they spin the ball, who is pulling this ball right now? So the answer is the object. So at this point, the weight of this object, which is equals to mg, will be equals to the centripetal force. So it is very easy to be confused, which is the weight provides the tension, pulling the object Fc to produce the centripetal force to allow the object to turn in a circle. Okay, what's next, guys? Now, so of course, this is a very simple. So how do we calculate the centripetal force, you might say? So F is equals to mv squared over r, Fc. So this gives us our third formula for today, and also which then we can summarize if you want to find the acceleration, or also known as centripetal acceleration. It will be equals to v squared over r, which is formula number 4. So if you want to find acceleration, you use v squared without the m. So if you want the force, you have to multiply F equals to ma. So that's why you're going to have mv squared over r. Okay, so guys, make sure you write this down if you have a piece of paper. Okay, now what is the tough one here? Okay guys, the tough one is when you use centripetal force in the case of planets. For example, so let's say now this is the sun. Orange color obviously is the sun, right? Okay, now if this is the sun, I have Earth which will rotate around the Earth. So now here comes the question, guys. How is the Earth being able to go around the sun if the sun has no hand to pull the earth. You see, obviously sun has no hands, right? So how does it pull the earth towards the center? So no hand, never mind. Sun say, I have big mass. So if I have big mass, I will be able to produce a very large mass to produce a very large gravitational force. So the reason why your earth is still attracted to the sun is due to the presence of your gravitational force to be equals to your centripetal force. Now guys, watch where the magic happens, alright? Now, so we have the first formula from the top, gravitational force, gravitational field strength, gravitational acceleration, centripetal force, centripetal acceleration, and now we reach this part. So remember guys, I want you to focus up. So what we will know here is that we know that this will be equals to gmm over r square. Centripetal force is mv square over r. So what you will realize here is that, so who is the big mass here? Obviously is the sun. Who is the small m here? Obviously is the earth. And because in your centripetal force, we will use the small object. So that's why you realize that this m and m will cancel each other out. This r and r square will cancel each other out. So immediately, the first evolution of formula is going to be produced. I can take this and I put towards the side now, guys. And when I try to throw the square root to the other side, watch me guys, I throw this square root to the other side, I will have the formula known as gm over r, which is equals to v equals to gm over r. So what is this v? Now, surprisingly, this v has many random names. You can call this as a linear speed, which is also linear velocity. Or you could also call it the orbital speed, which is also known as the orbital velocity. So it's linear speed, linear velocity. So usually, we use this v to calculate the moving object. Okay, so let's say Earth. So the moving object is Earth. You want to calculate velocity of Earth, so you use velocity of Earth. But this m, you have to remember that is the big M. Okay, so what do I mean by that? So if you want to calculate the velocity of Earth, you need to use the mass of the sun. If you want to calculate the velocity of Moon goes around the Earth. So if you want to calculate the velocity of Moon, then obviously you have to use the mass of Earth. If you want to calculate the velocity of a satellite, you have to use the mass of the planet. Okay, so remember, common mistake here. Let me draw a star here. So therefore, there is a careless mistake here. Sub wrong M. Let's go towards the right hand side, guys. Okay, on my left hand side, sorry, you will see that this formula boleh dipecahkan into a few more different versions of formula. Okay, why would I show you the derivation? Guys, this pretty much is very useful. So if I say that this is formula number 4, I will call this as formula number 5. Wait, this will be known as formula number 5. And then this and this is the same thing, guys. So that's why I prefer to use the right hand side one, formula number 5. What about our formula number 6? So there is a mini formula here, whereby it goes with this v equals to 2 pi r over t. Okay, this is parked under common sense formula number 6, whereby v equals to 2 pi r. So what is 2 pi r over t? So 2 pi r is your circumference. So this 2 pi r is actually the circle of the moving object, and t is the time taken for it to move. So if you have circumference, the total distance traveled divided by the time taken, guess what? You will be able to find the velocity of the object. Okay, so I will now substitute velocity equals to displacement over time, 2 pi r over t inside. Okay, so we will have 2 pi r divided by t square, gm divided by r. So guys, can you tell me what is my next step? So my next step is I will book up this thing, and then I will have 4 pi square r square divided by t square gm over r. So I will then now susun again, alright, so that I get a formula whereby I put my m on one side. So this will be 4 pi square r cubed over gt square. Let me do this. Okay, I'm gonna bracket this thing and then tell you that this is formula number 7. Okay, so remember guys, now when we calculate the mass of the sun, let's say, in our picture here, so this R is what? It is the distance between the sun to the earth. Okay, so you cannot just say the radius of sun, the radius of earth. You can either say the distance between the center of sun and center of earth, or if you really have to use the word radius, say orbital radius. The orbital radius, because that's the pushing one. So people just write radius, you will get it wrong. Okay? Now, so this is 4 pi square r cube over gt square. So if you want to find the sun, you have to substitute the earth punya period of rotation. Okay, earth punya orbital period. Okay, so guys, question time. Can I use this formula to calculate the mass of earth? The answer is yes, but at the same time, then you need to use the time of who? Siapa? Which one? So the answer is you have to use the moon, you have to use the moon. So if you want to find earth, you have to use moon. Okay, so it's the same formula, so that's not formula number 8, it's still the same thing. You just need to know which value to use. Okay, if you guys are okay with this thing, so we now have already 7 formulas, and tiba-tiba, we will break from here into another one more thing. So some of the books, especially textbook, they will give you another version of the formula, whereby they will say T square is equals to 4 pi square r cube divided by gm. Okay guys, do you think this can be called formula number 8? In my opinion, no. Because this and this, the difference between this formula and this formula is just your t square and your m change place. So it's the same formula, right? We have to agree on that, right? So I don't call it another formula, but I will say that this will be known as formula number 7 as well. Okay? So therefore we have this formula. Okay. Now, we will then go and see the next one. So what is the next part? So we will have Kepler's law. Alright? Now for Kepler's law, to summarize what is Kepler's law, we have Kepler's first law, second law, and third law. Whereby it is the law of orbit, the law of area, and the law of period. So OAP, orb. Okay? Now, for the first law, there are 4 words that I want you to remember. So you need to know the orbit of your planets are all ellipse in shape, whereby the sun is at one of its focus. So we have total of 4 words. Orbit, ellipse, sun at the focus. What do you mean by ellipse? Ellipse is it is the oval shape. What do you mean by focus? Focus is that usually if you look at the orbit of your planet, imagine if this is the orbit, usually your sun will be slightly on one side. So maybe it will sengit and to be here on one side. So it will definitely not be in the center, in the middle. Okay, definitely not that way. Okay, now what's next, guys? Okay, let's continue. So on the next part, you will realize is that for Kepler's second law, you have to remember 2. What is 2? So the area and the time interval is going to be equals. As for the speed, it will not be the same. Okay, so what do I mean by this, guys? So as I said, this is a 30-minute revision. So definitely I can't go very in-depth. So what is this thing all about? Okay, let me draw this picture for you. So if you remember, we said about the orbit is oval in shape. You will realize that, so this is where the one of its focus. So let's put the sun on this side. Okay, if your sun is on this side, now as your planet travels from point A to point B, let's say here to here, point A to point B, maybe they use a time of 1 month. But when they go from point C to point D, you see they move so little, but they also use 1 month. Okay, so if you have equal time interval, why you have to say interval? Because it goes from one point to the other, so that's 1 month. You will realize that the area that is connecting them together will be the same. So the area here and the area here will be the same. However, the velocity at AB will be greater than the velocity at CD because why? When you are nearer to the sun, your gravitational force increases. So therefore, you will need to travel at a higher velocity so that you don't get pulled all the way into the sun. So nearer to the sun, run faster. Why? Because it's very hot. Okay, so imagine if it's very hot, you have high kinetic energy, so you must run faster. So remember, the nearer you are to the object, you have to run faster. That's it. Okay? What about our third law? So for third law, it will go into our 8th formula, whereby we got t squared over r cubed to be equals to t squared over r cubed. Okay, guys, remember the way I write this formula will be slightly different with every other teachers or maybe method or even textbook, because it is the same, but it's just that the way I susun will be different. Because what is Kepler's third law? Let me explain. For Kepler's third law, I prefer to explain it as such, whereby you can faham it as the rule states that Kepler's third law must have 3 objects. Okay? If you have 3 objects, and when the 2 objects go around the 1 object, the 2 object goes around the 1 object, your Kepler's third law will be valid. Okay, what do I mean by that? Okay, so let's say one day you read a question and they say that so there is a sun. We realize that the Earth is the time is berapa, the R is berapa. Then we have Mars, where the time is berapa and the R is berapa. Okay, so guys, can we do Kepler's third law with this question? Okay, so now we try and check first. So usually they'll mention the sun, the Earth, and Mars. Correct. So if I have 3 objects, usually there will be high chance that it is a Kepler's third law. Then I have to check. So Earth goes around the sun, Mars goes around the sun. So I can use the t squared over r cubed of Mars to be equals to the t squared over r cubed of the Earth. Alright? Now for more contoh, you can refer to another video where I will be purely doing latihan only. Okay, I will link it at the description below. Now, so we have t squared over r cubed, t squared over r cubed. Then you will realize that this is valid, a valid Kepler's third law. Okay, now guys, let's think. If my Kepler's third law, I'm gonna do it this way. Let's say I have Earth, I have the sun, and I have the moon. Can I do t squared over r cubed of moon to be equals to the t squared over r cubed of the Earth? So if they give me all the information. Now the answer is no, you cannot. Because moon pushing around the Earth, but the Earth pushing around the sun. So if they don't share the same center, Kepler's third law cannot work. If they don't share the same center, Kepler's third law cannot work. Okay? So therefore, you have to try some questions, then you will understand better. Now, let's go to the last part. As for the last part in this video, we are going to talk about specifically geostationary satellite. So guys, please make sure you go and study what is the definition of a geostationary satellite, what is the characteristics of a geostationary satellite, and what are the uses of the geostationary satellite. It is very easy, which it is just pure theory question. For geostationary satellite, it is actually, you just have to know that this has the highest chance to come out as an essay question. So if there is anything that you have to read, baca, it is always geostationary satellite. And in your geostationary satellite, usually what calculations are there? Number 1, So do you remember the escape linear velocity? So you will refer back the formula number 5. So in your geostationary satellite, so we use this formula very often. So of course, there is another one more new term that we use here. It's called the escape velocity. So what is escape velocity? So escape velocity is where we need the rocket or whatever object to fly all the way, to escape all the way to space. So what are you trying to escape? You are trying to escape the Earth's gravity, the gravitational pull of Earth, and that will be the escape velocity is actually what is the minimum velocity to run away. So meaning to say, if I say my escape velocity is 100, so if 99, you cannot run away. But if you have 101, then you can fly away from Earth. Okay? So what is the formula? Now, there are a few things that I want you to remind you. Now, remember, kinetic energy is equals to half mv squared. I will not label this as a formula because I feel this is common sense. You learn in Form 1, Form 2. But then there will be a formula, which is called gravitational potential energy, which they will put this negative sign, GMM over R. Very commonly mistaken as GMM over R squared. Okay? Now the common I'll say confusion among students is in the formula sheet they will never write it as GPE. They use a very weird symbol like a capital U, so you need to know big U means gravitational potential energy. Now, in order to escape to space, I need sufficient kinetic energy to produce gravitational potential energy, to run, to escape from the gravitational potential energy. So when I combine these two formulas, my formula will appear to be 2gm over r, which I will call this formula as the formula number 9. So if you ask me how many formulas are there in this chapter, I would say that there are a total of 9 chapters. Of course, there is evolution of it. For example, we sometimes also use this as v equals to square root, the mini gravitational acceleration, 2gr, 2gr, okay, and also, this small g is the acceleration. Do not confuse big G. Big G is your universal gravitational constant, the 6.67, alright? And also for just now, this one, they might also make it to become GR, whereby equals to V. What are the odds this thing will come out? I will say very low, alright? That's why I don't put it under my main formulas. So there you go. Things that you have to study after this is just all these characteristics, all this theory related to this, and in my opinion, do not estimate a question which is related to centripetal force, because that is also a very common exam question. So my personal favorite in this chapter is 3 things. I really like Kepler's law, I like to do geostationary satellite essay part, and also this centripetal force question. Alright, should you be memorizing definitions here? Yes, the definitions that you can remember is the definition of Newton's universal law of gravitation, the 3 Kepler's law, escape velocity, and also centripetal force. So I try to shrink down the things that you need to know. So hopefully a short recap like this works. Guys, if my words is very ugly, please do tell me. Hopefully I can improve on my writing. If you like episode like this, please drop me a like. It will help with the algorithm that they will recommend this to more students, and I'll be able to help more people. So thank you very much. And I hope you will see the next episode. So for more latihan regarding gravity, please go do for more latihan on this gravity, please go down and check my description. I have 2 to 3 videos on gravity, purely just exercises. So I hope this will be able to help you.